Okay, so this will be like a short intro for you who hasn't been here before. This started out as a effort to trying to fund a new version of Caustic, the great app, either by buying off time from the developer so he could make a new version, or buying off the program as open source and making it open source. And both these attempts failed. Caustic has now gone out of business. I don't think you can download it from the Google Play Store anymore, and the website is down and everything. And no message from the developer, so it's a bit strange. I spoke with him earlier this year, and or maybe it was last year, and he told me that he got ripped a lot of revenues from cracked licenses. A shame, but still, I think it's a bit funny that there is no information what's going on. So and so everything has evolved from that into that I'm trying to rebuild something that is similar to Caustic without knowing neither DSP programming or the Juice framework that well. But how hard can it be? Caustic, in essence, Caustic was like a graphical thing built on top of the fmodx engine. So fmodx was an audio engine, and then the developer built a really nifty UI and also software synths that made up this funny app. And but now the next chapter of this video is 5 reasons Caustic sucks. So let's get into that. So I should change the scene here. I'm a bit new to this. The involuntary influencer here speaking. I hope you can see my screen. I'm running Caustic in Linux. And five reasons Caustic sucks. The first thing is that it doesn't allocate voices correctly. If I play, I should bring up the volume a bit so we can see it a bit more. I hope your ears don't mind. Let me do like this, and as you can see, I'm using a theme here. I think it's called Julia or something. Let me see what I call that theme. Julia, yeah, it's a high-res theme. One of those things that just got created from the community. I think it's a shame the way things ended up. Anyhow, one thing that's wrong with Caustic in the audio department, because I have been digging quite a lot in how it's built and so on. So if I turn up the release, and I need to use my headphones just to hear what's going on here. Yeah, we can take away that LFO, it's just annoying. Take down the volume a bit further so we don't need to listen to that annoying sound. You can see that the meter goes up even if I play the same note. That shouldn't happen. The same note should not trigger another voice. Think of a guitar or anything. You hit the same note, you hit the same string. You shouldn't have 2 strings running. So, and sometimes they cancel out each other because of that the next note is in the opposite phase of the first note. So if we take like pure sine wave, our chances are bigger. Let's see here. Yeah, a little bit phased out there. Come on. There, you hear poof, it disappears. So third note cancel outs because we are not retriggering, we are making a new voice. So that's bad. Another thing that's really annoying is that the LFOs, my god, something with them that's not right. And you can also hear it if I have a modular, just a white noise running to a phaser, I think it is. And when you listen to the result, it doesn't sound right. It just doesn't sound right. There's something wrong with it. So that sucks. And also the effect department, I mean, when we're speaking about effects, the distortions, oh my god, they are really bad. They are just clipping like a digital converter running out of space. They are horrible, most of them, and really simple algorithms for that. And also another thing that sucks is that the patches, if you have a patch and you make a great sound with some effects and blah blah blah, blah, and you save that patch, you don't save the patch with the effects, so they are lost. You may have had set up some fancy thing here in the effects, and they are not saved with the patch. That's a bummer, I think, because without the effects, many synths are quite weak. And another thing that's really annoying is that there's no master tune. You can't set. You have to use 440 if you have made a recording on a guitar or anything that's not 440, and you want to match that with. You have to use a rubber band or some, funny algorithm that just makes. I don't like them, and it's so silly that there's no way to change the master tune in Caustic. And also one more thing is that there is no MIDI out. It's so obvious. You have an instrument that can control Caustic, but you can't get any MIDI out of it. And the explanation for that is really that the engine that I told you about, the F-Mod-X, it didn't have MIDI capabilities, and neither does its successor F-Mod Studio. It doesn't have MIDI either. So the MIDI in on Caustic was built custom made on top of custom made by the developer. So that's maybe an explanation why there is no. You should be able to just select a synth here and choose a MIDI out synth, so you can control whatever external device you have. So that's a bummer too. Okay, so. Just some things that are, and also the digital noise. I mean, listen to this. I use a square and I put some. I don't know if you can hear, but it sounds really awful. If I take up that an octave, let's do like that. I will do that. Bring down the volume a bit. That's not nice, man. Let's listen to the high quality. It's better. Yeah, clearly better. So I mean, the low quality waveforms are really bad when it comes to noise. It sometimes can be fun, but and the reason is because if you click here, long press, and load a waveform, they are super sharp, and they shouldn't be, because you break all the then you have to use digital filters to if you just had something like this, then you'd be better off with not having the same kind of crazy digital noise going on. So that's just annoying. Yeah. Okay. So what's been going on? What have I been doing? I've been building this breadboarding in PHP that I called Echo, and I am. You can download this. I give the zip in the description. And this is written in PHP. There is no composer or anything running. You have some require blah, 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 but no composer. None of that. So you just have to download PHP. You have to install the extension ImageGD to get waveform graphics. Let's go through it. We have a test folder, and I benchmarked. I made a synth that is called waveform. That is just doesn't do much. So I have a script called bench, and I can run that. So if I run PHP bench PHP like that, it takes a while, and it generates a WAV file for us, and it takes 33 seconds to generate. Hang on. It takes 3.33 seconds to generate a WAV file of 1 second. And this WAV file consists of 25 voices. If I do that in C, it's made in like 10% of this. So here we are utilizing, we have like 300%. We are running out of buffers. If this would be a real-time system, there would be no chance it could do it. But in C, I think we are doing it in like 3%. So the ratio is like C is at least 100 times faster than PHP, which, you know, just good to remember if things takes time. So, but if you just look at the test, what it does, bench. So it requires the app that it's like a mock of the program, consisting of some racks and some message queue. And I mean, this is really, you know, we are breadboarding here, so nothing is settled. So just like Caustic, we are having 14 racks, and we have a rack render size of 128. And why so low? It's because, you know, we want to have a sequencer that is capable of generating ticks quite close to you know, that so that the differences isn't so easy to spot. And I can show you that later in Caustic. That Caustic does the same thing. So we have a rack render size of 128, and then we have a master render size that is here 1024. It should probably be 256 for better latency, etc. But you know, there's a big difference between the rack render and the master render size. This is related to the audio buffer. This is related to how much we can do in one stroke before checking if we are aligning to, if we are reaching a new you know what it's called, F8 clock. So we are using 24 pulses per quarter note. So that's, you know, in an ordinary song 4/4 on a 120 BPM, it's like 48 pulses per second. So to get that accurate, we are using a small track rendering size. So after each rendering, we check if we have, because the playhead, as we generate the racks, we are moving the playhead forward, and then we need to look if we have done so many samples that we are approaching a new pulse. And here we have the master tune. We can just change it to whatever we want, and we get, you know, can play in 432 and play with Bob Marley or the Doors or anything. So yeah. So, and we are using racks, and I use PHP because it's similar to C, but of course it's not, you know, and it's much faster to breadboard with, and I can understand this code myself. I don't have to learn C at the same time as I'm learning DSP. So this app is quite small. What it does is that it loads the DSP core, and the DSP core loads a bunch of oscillators and noise and attack release and ADS HR. Note that we have like H here that I really missed in Caustic when playing with the real keyboard. and another. I think there's two here. I think one is linear and one is logarithmic. And I'm, as I say, everything is quite. It's not settled. And LFO and butter. Yes, that's a low pass filter. And interface, just an object-oriented interface for the synths. And so here we set up some wavetables, and I'm experimenting with not having like regular, like Caustic does it. Instead, I'm generating squares based on the harmonics. So just to check if that gives better digital noise performance, and some node to hertz, and that's it. And then we have the rack. We can go back to let's go back to the test, what it does, the bench. It kicks off the app, and then the app gets initialized, and we choose to set up a rack with one synth, with the waveform synth. And then this is really my synth. It's just a bad code copy from when I experimented with the subsynth. So this should really be my synth, but you get it. I set the number of voices to 25 here, and I push the settings so that they are submitted to various registers. In a synth or an effect, you have a property, an array of contain with the various attributes, and then you have to call the method push settings so they are distributed to the various mocking the registers, or just like a real synth, and also to so that the DSP algorithms can be as fast as possible. And then I require from the utils a WAV writer, because I want to write a WAV file, and I write the WAV file here, and I also make some benchmarking in time. And here you have 344. What's that? Well, that's since each rendering, as I said, was 128, so you get 344 times 128. That's, what is that? Oh my god, what did I do now? 344 times 128. Yeah, exactly. So it's more or less 44.1 samples. 1 sec. So there you have it. And then we close the WAV file and we close the app. So that's that. You do it again. We can run the test. It takes so slow. And if I just lower this to 5 voices, let's do it again, and it should be faster. Yeah, now it's faster. So it generates 5 voices in. And how does it choose the voices? Let's look into that. It loads the waveform synth. So if we just look in the waveform synth, we have the model that is like the low-level part of the synth that is supposed to run as fast as possible. Also containing settings, and I'm looking at in a way to make this as simple as possible with all the parameters that you need. And I'm probably looking at XML in the future, but currently it's just JSON. So you have these settings here that you end with file put contents into JSON file, and that is so a web-based mocking tool can pick up it. I will show you in a minute. So anyhow, here you have the push settings that set up oscillators to what we chose. So here is like init settings. It's voice is 25 by default, but I can choose to. How did I do that? I've forgotten. Let's see. Bench. I do. It's not brilliant, but it's okay. I mean, as I said, we're breadboarding here. Some things may change, and we have like this implement synth interface. So we have an interface for the synths that they need these methods with these arguments in their methods. So that's that. So that's the bench test. Then we have a subsynth test. That should be okay. We can run it. PHP subsynth 1. Sorry for the annoying noise. I hope it doesn't hit your ears too hard. If I run that and then play it, what was that? It was this like a mock of the subsynth with some delay. So we are utilizing the delay is not in the synth, it's rather in the rack. So if we look at this test, we are launching the app and we are setting up calling the subsynth. And here we are also in the rack, we are loading the effect delay. And we are loading the web writer, and we want to write a file. And now we are setting some parameters, sustain, because if you look at the subsynth, here we have the subsynth model. Yeah, there's a lot of defaults that are set here. But then in the test, we are setting some parameters this way. And in the bench test, we didn't have to use note on because it just was a benchmarking test. Here we can choose to have note on. That has 3 arguments. It's the MIDI number. So here we are hitting A4 and with the velocity. And this number isn't used, but it was thought to be used as a delayed execution, so that you get really precise timing when the note is pressed, so that within buffer processing you have a delayed execution of the actual start. But I discarded that because I dug into how Caustic does it, and I think it's fine for now, so I skip this idea. It's just overwhelming at the moment to do that too. So here you have some note on, and a note off, and it's the same thing. You have the MIDI note, the velocity. It's never used, right? The velocity and note off is never used in, I don't know, any instrument that does it. Maybe some Arturia or something, I don't know. Anyhow, and between each is really simple. That isn't related to any kind of clock. It's just render frames, 128 frames, and as I said, a rack buffer size is 128 by default. So here we are triggering one note, and then we play chord, right? Now we are playing 2 different notes. Here's the chord. So that's what you hear. There comes the chord. So if we just want to increase the velocity of that chord, we just do like that. And it should be, yeah, there we go, a bit louder. It would be interesting if we could hit the distortion level, because I'm looking at how to make the distortion a bit more analog. But let's skip that for now. And it's the same, more or less the same. I haven't run the Subsynth 2 test for a while. Let's see if it works, because if it doesn't, it could be, you know, useful to just see what needs to be fixed. So let's run PHP Subsynth 2 PHP. Okay. Oh, bummer. What's going on is that I changed this from being like you just state how many frames you want. Earlier you stated how many samples you wanted, so this number is way too high. So I need, since the frame isn't 256, it's 128, I need to double the other number. So 256 goes, and this is 128, and this is 40. This is 256. I can just do like this instead, right? Yeah, that's easier. That on render. Come on. Yeah, okay. Let's try. What does it do? We don't know. Let's look. What does it do? Maybe it does the same thing. Play another note. Play chord. Maybe it's something else. Let's see. Play Subsynth 2 PHP. Okay, there's no effect. There's no delay effect. Right. So we could try to add a phaser or something. Yeah, here my delay. Run it again. Yeah, there we go. Okay, that was super fast. Yeah, there we go. If we look at how the delay is written, the effect of these are also in different folders with our settings in JSON files. So this delay model, it doesn't have an interface yet, but it should have like a interface also, the effects. And here you can set, it's the same principle that you have the settings in here, and that you push the settings so that the actual processing that goes on when you need to render a buffer is as optimized, so you do as little math as possible. And this could probably be even more efficient. So this is just, you know, breadboarding. But it's fun. It's fun. I can really recommend playing with this, because I mean, most people have touched PHP, and it's quite close to C. So you can always ask ChatGPT or something. I got an answer about the when it comes to filters. I don't know filters at all, but she spat out this, or whatever you should call it, spat out this to me. I don't know if it's any good, but let's move on. Because we have another thing that is fun to play with, and that is we have a web interface. So if we go, this is like the main directory, and if we go into www here instead, it's the same as you see. It's the same as you see here, right? There we go. So we start the built-in PHP web server, and then you need to just use a port that you're allowed to start. So that's like standard. And you just have to enter this directory and write like this. And this is platform independent. You can run it on Mac, Linux, Windows, whatever. So there you go. And what happens now is that if I now reach this, you can always kill, if you mess up, you can always kill this by typing cmd reset, And then you choose like synth. So here I choose the waveform, and the waveform obviously doesn't care about any play sequence. It does the same as, oh my god, it's so slow. What's going on? What's going on? What's going on? I need to look into this. Something is wrong here. I need to fix that, because it's probably the same problem, right? That, yeah, exactly. Something is wrong here. Post, let's see what's going on, index. It's just, this is really ugly here. Renderer, it's probably in here that we are rendering way too much. Parse sequence. Yeah, times. Let's do that instead and see if that works better. Come on. Come on, come on, come on. Yeah. So there we are. Not too interesting, but if we launch the subsynth instead, and there's no auto update. I mean, this is, once again, this is breadboarding. Make this better, please. But now it reads that JSON file from the synth directory and creates these small boxes where you can type stuff. So if I play this now, I render it and I play it. So we have like, let's play a C. So we play a C plus an E plus G for 10 frames, and then we pause for 10 frames. So that's everything we do now, right? So we have like a major chord, and if I change that, we get a minor chord. And we have like the first oscillator. You can see it's the way I'm mocking the subsynth here. So all the parameters and some new that I think that would be fun to have. Well, okay, not all. Some are missing still. But you have the waveform and waveform, and if I can take away the modulation completely, and we just use the first oscillator. So then we should get a sine. Why does it look funny? Why does it look funny? Because we have a filter probably. If I bring that up a bit. I'm a bit puzzled why it looks funny, but let's. It's because we are hitting 3 tones, of course. So let's just hit the C. Then we should have just a sine. Yeah, perfect. So there we are. And if you see, I have oscillated 2 octaves up. So if I choose to mix just with that, we get 2 octaves up. Yep, and we can mix those signals, and we get like that. And we can also do like that, just use the first oscillator, but modulate the first oscillator using the second one. And maybe use like that, and the modulation level like that, and we should get something, yeah, something like a square wave. So now we are in FM synthesis. The filter I have here, I don't know if the code is anywhere near correct, so I don't trust that really. We have some new parameters here going on, like the LFO attack. So if I have an LFO depth of, like, say 0.3 and an LFO attack of 1 second, you get a nice, it's a really nice effect. that I think is really missing in Caustic, and also I think the LFO sounds way better. And you can choose the square for the LFO, the waveform for the square. Let's see if that works. Yeah, you could hear it, right? But we can push it a bit like that. So you get the ramp. You get the ramp from the attack, and you get the rate. So if you bring up the rate, we should get, yeah. We make it a bit longer. So we play it for 20 frames, and then, yeah, let's do that. There's something with this code that I'm not sure it's, because I mean, something not working here with the pause. I don't know what it is, but there's something wrong there, because you should hear the tone. 60. Let's do it like that. See if that triggers the pause. It could be that it doesn't take the last. Do it like that. Hang on. I don't know. But my point is what you can use the hold. That's like the thing that I really think is great. That if you this is like you're pressing the note, but you still, the sustain level isn't constant. It decreases slowly. So you have like a release, may have a release time of, let's say, 500 milliseconds, and then a hold release time of 3 seconds. Super annoying that this says, look at it, we are using this, we're looking at the wrong, because this is the VCF. So we should look at the VCA. Let's do that instead. It should be called DCA, but yeah, there you go. So you can clearly hear the release when the note is being released. And the hold is, if I now it will decay even as it's pressed. Yeah, so there we go. So that's that, and what I'm looking at now is how to bring in a sequencer. So because I mean, you can use the traction engine in Juice, but I think I don't want to, because I don't want to be too tied into like a third-party library. I really like the platform independency capability of Juice, but I don't want to, just dive into the ocean of Juice and Traction, because Traction seems quite complicated, and I'm sure that there are parts that I really want to achieve that Traction won't solve. I know that's arrogant, but I'm quite sure that I can achieve in a more clever way if I just coded this myself. I could be wrong, of course. It's just that it happens so often that you use like this super great huge library, and at the same time there are some parts that you can't reach. So I rather code this myself. And to finalize this quite long video, I'm just showing you, let's make a new, because regarding timing, let's make a new project here, new, and we can add a machine like the drum machine. And if I would use the highest resolution here, oh my god, that's so high volume, my god. I don't know how it is for you, but let's see here. Is that better? probably. That's okay. Select all and copy them. Did we? And now paste them, paste them, paste them, and we should be fine, right? Yeah, so we have like, okay, as well. And if we take that down to I think you know where I'm going with this. Where's this one? So, what's going on here? I think we can hear it. There you can hear it quite clearly. Yeah, here you can hear it really clearly. I mean, it isn't super timing, so if I now just do like this, I go into song mode and I go, do you know, by the way, that if you double click this rack here, you write, I think that's one of, it's so neat, those little things that really is clever made. Okay, there we are, and we can now export this into just a test and export it. Yep, done. And we use the same, we can use another synth, we can use load that, load, and we should probably be in songs export. There we are. Oh, it's quite small, that was a bummer. How do I do it? I'm used to using a phone. Bummer, how do I do this? How do I zoom in? How do I zoom in? I actually don't know. I'm giving up here. The point is, what you're hearing is that, okay, I just do like this. And we hope that it will crop. Yeah. I'm not looking for these like sharp things here. That's not what I'm talking about. I'm looking for that they should be triggered. If I use the tempo 150, they should be triggered on 0.25 if you do the math. But they aren't. They are constantly being triggered a bit earlier, but really different. So they are not in perfect sync. And that is what you hear. You can hear like the small, if I mute this and just go back to that, you can hear that this isn't really, it isn't perfect, and it has nothing to do with the setup that I'm running this in Wine in Linux. It's a core part of Caustic Audio Engine. So I'm mimicking that by using, as I said, the buffers in the synth of 128 samples. I think this is good enough for, you know. So that's that. We don't need traction engine. So this was rather a long and a bit technical description about the project. But I hope you liked it, and I hope you're fine, everybody. So yeah, if you want to participate, just, you know, send a note or something. Just be happy. Cheers.